And then what I'm going to do is I'm going to place a pry bar between one of the throws and one of the main bearing caps and pry the crankshaft forward and see how much forward it goes, and there will be a specification in your service manual for that, or your Haynes manual. So let me go ahead and zoom in on the gauge and we'll see what we get. All right, so we're zeroed and I'm going to go ahead and place my pry bar in, and we can see we've got, what do we got? 8 thousandths, exactly. 8 thousandths of play on the crankshaft, so I'm going to go ahead and I'm actually comfortable with that because I'm pretty confident whatever the spec is, the new bearings are going to keep it within spec. And much to my amazement, there is not a spec shown for that on here at all. So I'll have to look that up elsewhere. So that test is a little bit inconclusive, I admit, but I'm pretty confident that you know, if that was like, you know, 15 or 20 thousandths, maybe I'd be a little more concerned. But we're going to go ahead and remove the crankshaft now. And we don't really have to take all that much of a look at it. But what I do want to do is another very important test, especially considering the condition of those pistons. I want to do a bore measurement. So let me get this crankshaft out of here and then we'll go ahead and do that. All right, and I should point out, I suppose, that similar to the rod caps and some of the other things where the torque sequence is a little more important, cylinder heads too, I tend to do this a lot, especially if they're aluminum, maybe not worried if they're cast iron. But I'll go just a quarter of a turn in kind of the opposite of the torquing pattern, and just a quarter of a turn until the bolts loosen up. And I'll just keep going around like this, and this is just to help to prevent any kind of warpage or anything like that. And again, I'm especially concerned about this more on aluminum parts. So let me go ahead and get these loosened up and I'll be back. All right, once I've got them loosened up, I don't mind using my air tools or anything to make things a little quicker. So one of the things, again, keeping with the theme, is your orientation and reinstallation is everything. So before I remove these caps, I want to make sure that I can put them back in the exact locations and the exact orientation that I removed them from. So what I'm going to do is get my little stamp kit. And normally these are numbered already for you, and you'll have like 1, 2, 3, 4, 5. Sometimes M1, M2 for main bearing or whatever. The trouble is these are so dirty. Well, there is a number 1 here, it looks like. But just to be safe, what I'm going to do is, again, use my stamp set to go ahead and label these up so that I can be absolutely certain these go back where I found them. All right, and to get these caps off, I find it's best to use the bolts as kind of a handle, and I just rock them free until they come out. And that one is out. So, well, we definitely have a considerable amount of bearing wear on the mains there. So not that it matters. We already know we need to redo this crankshaft, but let's see. And that does not pass the fingernail test. Even through my glove, I can catch on my fingernail. All right, on this one, this is the thrust bearing that I was talking about that I mentioned earlier. These, you usually have to kind of hammer them off or pry them off. You can see the bearing is pretty destroyed there. But this is what controls that end play on the crankshaft right there. And your end caps are going to have your front and rear main seals usually. This is a 2-piece rear main seal that's in there. Always replace those, always, whenever you do this. This crankshaft is going to be really heavy. If we were worried about the conditioning of the crankshaft and everything, then we would be a little more cautious with this. But what you want to do, you don't want to rotate the crankshaft in this position because you might rotate it out of the bearings and then scratch the journals up on the block. So the best thing to do is just wiggle it a little bit until it comes out, and it's very, very, very heavy. Then I go ahead and remove all the bearings. And usually at this point, it's a pretty good stopping point. So what I will do is I will spray down the entire block and all of my pistons and all of the parts and the crankshaft and everything with WD-40. It's a great way to preserve them, prevent rust and things like that. And then you can store them in a plastic bag, cover the block with a trash bag. That's typically what I do. But before I do that, I do want to go ahead and do a really kind of dirty bore measurement, and then we'll be able to assess pretty much what we're going to do for machine shop work on the lower end. We still have to get to the cylinder heads, which is a whole different thing, but again, I'm not nearly as worried about the cylinder heads as I am the bottom end of this engine, because I know that the compression problems with the engine are on the bottom end and not the top end, so I do want to check that before I stop. I like to loosely thread the main caps back in place again, just to be sure that I maintain the orientation and don't lose them. And that'll be just fine. So you've probably noticed the recurring theme that there is a lot of detail orientation in maintaining things. One thing to keep in mind is, you know, it's been 2 days now since I've even pulled the engine from the truck. You've got to keep in mind that you could spend months on a project like this, months. So you really have to kind of be a good note taker, taking pictures, video, things like that. It may be a month before you get your parts ordered, things like that, and start assembling. And are you going to remember how this stuff goes back and what orientations they go and everything? And then are you going to be able to remember how to put it back into the truck and rebuild everything? So another disadvantage with this method of doing a rebuild is if this is on your daily driver and you need to get to work on Monday and it's Friday, there is no way in hell that you are going to finish this. You really need to consider the time investment that this takes. And also, so far, the only really special tools that I've used are a feeler gauge. But you're going to see on the reassembly, if we get there, I'm kind of a little worried, I got to admit, but there's a lot of specialized tools that are only ever used for engine rebuilding specifically. A feeler gauge is used on a lot of things. A dial indicator gauge can be used on a brake job. I actually show how to do that in a video. But some of the other tools we're going to see, like a piston ring remover or a dial bore gauge or things like this, are only ever going to be used in this application. Your investment in those tools, if you only do this once, adds to your expense and may change your consideration on doing this project. All right, I am back to the top of the engine now, and one of the things I want to do is, let me get a cloth to clean this up. Because of the compression readings that I got, I'm a little concerned about our bore diameter, and I think if I remember correctly on this engine we're supposed to have a 4-inch bore diameter. Now there are special tools you can buy, bore dial indicator gauges. They're sort of dial indicators that are T-shaped that you can stick into the bore and stick at different depths and different orientations and read the average diameter of the bore. Look for out of round, look for if it's you know, out of spec by however many thousandths. And I actually don't have one of those. They're a little bit pricey, and again, you know, being a budget rebuild, it's unlikely that you would invest in a lot of tools. So I'm going to show you a different way that I do it that actually I think is better, because I'm not really so much worried about the bore diameter as I am the piston to bore clearance, or in other words, how loose the piston fits. So this will be easy to do with my little piston organizer here. This is going to be the piston for number 1 here. So I've removed the rings from the piston, and later on I'll show you how to do that when we do the piston preparation. And the point of this is, when I put the piston in here, of course, there's going to be a little play, a little slop there. And there is going to be a specification for that. And I looked it up, and it's going to be 0.0015 to 0.0023 inches. Notice how we're always working in thousandths of inches, so you really have to have accurate measurements. Just a thousandth of an inch can sometimes make the difference between your rebuild failing or not. So what I'm going to do is get a feeler gauge, and because our spec here is a maximum of 0.0023, I'm going to go ahead and get the feeler gauge for that, because I have a feeling that we are going to exceed that. And being a scientist, my feelings are irrelevant, but my feeler gauges are. So I'm going to go, here is a 0.0025. So this is actually over our spec. So if this gauge fits comfortably, we're going to have a bit of a problem. So what I'm going to do is, as deep as possible, I'm going to put my feeler gauge in with the piston, and there is a complete amount of slop. Now, what I'm going to do is also check for out of round by looking. So like here, it's a lot more snug. So this means that our cylinder is oval shaped. So here I'm going to switch to a 4/1000 gauge. And again, we can see we've got plenty of slop. I shouldn't be able to move this piston at all. The gauge should completely stick. And there it gets a little bit more sticky, but we've got almost double the minimum specification for piston to bore clearance there. That is going to be a significant concern, and it definitely explains our low compression, and I will show you why. So what I'm going to do, I've got a compression ring here, and I'm going to fit it in there. And as you can see, actually let me face it up more towards the camera. There is a gap right there. Now I have to get this square into the bore. So what I'm going to do that is, I've got this other piston here where I've removed the top compression ring. The top compression ring is removed, but I have my second compression ring, and by putting this, it will create a stop. Get in there. There we go. So that creates a stop so that I can ensure that my ring is square in the bore perfectly. And what we're looking at is there should be a maximum 20 thousandths gap here, and what I've got here is a 24 thousandths gauge, and you can see that it just easily passes through there. And as a matter of fact, that's the biggest gauge I've got. So what I'm going to do is actually combine it with a 15 thousandths for a total of 40 thousandths, and that even passes right through. So we're well over double the specification for this piston ring gap, and that means that we're going to have lots of compression going by here. Now, of course, part of this could be because the ring itself is worn, but the problem is, I know with this much gap, a brand new piston ring is still going to be well out of spec. So we've got ourselves an issue here. Well, our budget rebuild is not going nearly according to plan. So the problem I'm having with this is the only way, there's two ways that we can fix this problem. One way would be to what's called sleeve the cylinder, and that would involve putting a sleeve so that the cylinder comes back to spec, and then theoretically we'd be able to reuse our engines and go back, or reuse our pistons, I mean, and go back to stock and everything. The trouble is, with the out of round that I'm measuring, I just don't see that as being a possibility, and I'll have to check with the machine shop. One of the nice things about doing this is you can rely on your machine shop for a lot of this math and figuring out stuff, but having been here before, what our most likely option is for this is they're going to say that they're just going to have to drill it 30 thousandths over or something like that. And the problem with doing that is several-fold. First of all, we've got another machine shop expense, and a pretty significant one, because now they're going to have to hot tank the block and everything like that before they do that. It's going to be a fairly significant expense to do that overbore on here. Plus, when we overbore, we're now going to need oversized pistons. So now we can't reuse the pistons, which I don't think we could anyway, but we definitely have a new piston expense. The other problem is that at that large of an overbore, it may be very well, and I'll have to see if the machine shop agrees, but I'm thinking the stock cam is not going to be able to deliver enough fuel and air mix with that much more of a cylinder volume. So we may well now have to invest in a oversized cam and lifter set. And we noticed that there was damage to the camshaft anyway, so that would have been an expense. So our goal of $500 in parts and machine shop service has now, by my calculation, added up to darn near $2,000. That is going to be quite a bit over the customer's budget. So at this point, I think I'm going to stop the video, contact the customer. If I can reach him, then we'll see what happens. But if not, I'm going to go ahead and start on the cylinder heads and do an inspection on those. But my apologies if it turns out that you've come this far and I don't end up reassembling this because we run out of budget. But in a way, it's kind of a good thing, because this is one of the things I wanted to show you. If you take on this project, this very well could happen to you, that you go through the expense of the tools and everything and find out that you've got a catastrophic problem, and now you've got to go back to another option like getting a used engine, which, as I said at the beginning of the video, is a better option anyway. So in a way, it's a lesson in reality. So anyway, thanks for watching. I'll be back on the next episode to let you know how this turns out.
Boom! What's up, biznitches? So I seriously messed up here, and I'm not referring to the selection of furnishings in the background. I'm actually at a hotel for the next couple weeks while I have to work with my real job, so I will not be able to update this video series for quite some time. And sorry for the camera work, I'm just using my camera phone because I wanted to update you guys so you don't wonder, whatever happened with this. So 3 points to this epilogue real quick. The first one, where we're at with the truck. Second of all, where we're going to go with the video series. And third, addressing a couple comments. So where we're at with the truck, I decided myself to advise the customer that it is in his best interest no longer to pursue this project. The problem is obviously we're well over budget, and at best within the budget, what I can do with this engine is probably spend $1,500 to bring it up to a specification where you would do a compression test or some validations on it and determine, this engine needs a rebuild. And just from a moral perspective, it's just a really irresponsible thing to do, to basically spend all that money to rebuild an engine that, when you're completed with it, needs a rebuild. The other thing that I didn't mention, this truck needed a lot of other work, and a lot of it that was, I believe, safety related. The steering column was severely messed up. It needs a good $300 or $400 in suspension work. So I really didn't feel comfortable basically having built this engine up, even if we were to increase the budget and fix everything it needed. You would end up putting basically a rocket engine onto a trash can with casters. Not that his truck's a trash can, but he's not seeing this video anyway. I decided not to show it to him because it would be somewhat akin to him watching a video of an autopsy of a family member, I believe. So what we're going to do is I'm going to look at other options for him. We're looking at used engines and stuff, but we're no longer going to continue with this rebuild. Now, that said, let's get to the second point, where we're going to go with the series then. Because I don't want to abandon this series, first of all, it is an amazing amount of work. You have to keep in mind that in this video I'm giving one example on every part of the engine, so I'm removing one piston or measuring the lift on one camshaft lobe. In reality, when you do this, you're doing this on 8 pistons and every lobe in the camshaft, and sometimes 16 valves, on a V8 engine, sometimes 32. So the amount of actual work involved with videoing this is a little bit more than what you might expect if you've never done this project before. So I don't really want to abandon it. So what I'm thinking that I may do is continue on with the dissection and diagnosis of what would be needed if we were going to continue the project. I think that one of my main goals with this channel, of course, is to help people that are in a situation, and with this video I can easily see where people may be like, wow, I've done everything that this guy said and I'm within spec on everything in my engine, so I want to keep going on. So I don't want to abandon those people. And then of course some other people are just curious to see how I would finish out this project. So that is what I intend on doing. As far as rebuilding the engine though, what I'm thinking I may do is probably just use the old parts and put them back into the engine, but show, if they were new parts, how I would validate that the engine is within specification. So I won't completely rebuild the engine, but just kind of put it back together to show what is involved, what tools you need, what's entailed. So I'm strongly considering doing that. So I think that's the direction we may go. And then finally, I'll try to make it quick, but I wanted to address a couple of the comments just in general on the channel and especially on this series. I apologize for offending people that are defending those that maybe don't know as much about auto mechanics and stuff. My intent is not to insult such people. I get a little bit perturbed when I'm talking about Haynes manual jockeys and things. At people that kind of like to talk out of their ass because they're sitting there safely behind their computer screen and like to try to, sort of deliberately demean people that kind of put themselves out there like I do. I know full well when I make these videos that there is a percentage of people that are going to meticulously watch the video for every mistake I make so that they can sort of, blurt it out there to make themselves look better or whatever. This is just my rebuttal against that type of behavior, because I not only get annoyed by it, but I find it damaging too. The whole point of my channel is not to be like a Eric the Car Guy or something like that. Not that there's anything wrong with his channel, but I try to make this channel specifically to help people that are a small subset of the auto enthusiast population, and that would be the do-it-yourselfers that want to take their diagnostic capability to a higher level. And for the most part, a lot of people just don't seem to get that and understand that that involves a lot more talking and thinking and understanding of theories than it does changing parts and bolts and everything. Seems the masses prefer the latter much more than the former, but I dedicate my channel to the few people like yourselves. If you are still watching this, you are the people that I made this channel for, and to be honest, I would like nothing better than to privatize the channel for only such people, but you can't really do that because I can't distinguish between the populations. So anyway, my reasoning for those type of rebuttals is I want to create an environment on this channel where basically people who are not interested in that type of material will find the channel maybe unappealing. And there is actually good reason to do that. One of them is I always try to answer the comments that are relevant to the material. On one video I did how to test if a battery is draining overnight, and then one of my favorite comments of all time, somebody was like, "My battery drains overnight. Do you think I need a new battery?" You're an idiot. So the other thing, if I'm talking about fuel trims and then somebody asks a question, well, how would these be affected if I had a turbocharger in the car? That's the kind of thing I live for. And I actually still don't know the answer to that question, but I try to help people that really are dedicating themselves to trying to understand these concepts. And the problem is when I get a whole bunch of asshats on the channel, then it dilutes my ability to respond to them because I can only invest time on this thing on the weekends. And when I get, say, 50 emails a day at this point now, and I'm trying to answer people's questions that are legitimate and really show that they've made an effort to understand the material, it gets diluted and lost a lot of times with all of the people that are just being idiots. So hopefully that makes sense to you. I'm not saying it's the best way to do it. Is it the right way to go about it? I don't know. Maybe, probably not. Is it elitist? You're damn right it is, because I'm trying to appeal to a certain subset of people. And the truth is, it's working. If you look at Eric the Car Guy's channel, not that I'm picking on him, but you look at some of the comments, you'll get an argument with people where somebody might say something like, oh, well, if your compression is low in the engine, try a higher octane fuel. And then somebody will argue, well, you're an idiot, the computer controls the compression. And to be honest with you, if those two idiots found my channel, I think I'd probably close my account. Compare that with the comments on my channel where just recently I had two engineers arguing about the theory of electrical operation in an intake air temperature sensor. And they actually both privately emailed me apologizing for kind of arguing with each other on my channel. Are you kidding? I love that. That's exactly the point. So again, that's kind of why I sort of create that sort of environment. I know everybody doesn't like it, but the truth is that's kind of effective, because if you look at the comments in my channel, almost always they're fairly intelligent and relevant, and that's kind of what I'm aiming for. And the other thing is I want to be able to help the people. You look at the video on the distributor installation, and every comment is like, oh my god, thank you so much for making this video, and that really makes my day. It is the only video on YouTube that shows you how to install a distributor in a 4.3-liter Chevy, and you can see the number of people this helps. I don't want my ability to help people diluted with people that are just looking to, be trolls. So anyway, sorry for talking about that too much, but I will be back in a couple weeks, and we'll finish up doing some more diagnostics on this engine, and we'll continue on with the series as if we were going to rebuild it. So anyway, appreciate all your comments. I appreciate everybody who subscribes, and thanks for dealing with me. We'll see you soon. Bye.